Here are the notes for 7.2.3 polynomial division. Hopefully this is a review from what you did in Algebra 2. The first way we're going to learn or remind is using long division to solve, and the second is using synthetic division. So remember, a polynomial just means it has more than one term. So we could have something like this, right, plus 2x plus 1, and we would be dividing by some factor of x. So you could divide by, just an x plus 1. And so that's what it's going to look like when you do polynomial division, all right? So here's an example of long division. Complete the following division problem. Express all remainders as fractions. So it's set up a little different than this one. Just instead of a fraction bar for our division, we have the traditional division sign, right? So don't let that freak you out. You're going to write it like you would set up a normal long division problem, like what you learned in like 3rd grade probably. So I'm going to take the divisor, which is this guy, and I'm going to put it in front, and whoops, in front of the polynomial that we're dividing into. So this part right here is going to be under the long division sign, right? So I'm going to go here. I'm going to write my 6x cubed minus 5x squared plus 5x minus 2. Okay, so once you're all set up, the key thing you want to look at is this first term. So I'm going to ask myself, how many times can I divide 2x into 6x cubed? Right, so I'm only looking at this first term and then this first term. So if I divide 2x into 6x cubed, that gives me a 3 and an x squared, right? And then from there, I want to multiply this term times this and this. And I'm going to go ahead and erase my color because it's going to get really busy otherwise. But that 3x squared is going to get multiplied by the 2x and the negative 1. Okay, so when I do that, I'm going to get 6x cubed, which that should happen, those should match, and then 3x squared times negative 1 is negative 3x squared. So notice how I'm lining up the cubes and the squareds. And then from there, remember in a division problem on this step, we actually subtract. So I'm going to change that to subtraction and this to addition because it was already negative. When you do this, these should cancel. And then you're doing negative 5 and positive 3, which is a negative 2x squared. And then we're ready to move on. We're going to bring down all of these terms that are left. Now, again, I want to just focus on this first term and this term, right? And I'm going to say, how many times does 2x go into negative 2x squared? So if I divide that, I would be left with just a negative x, right? Let me get rid of the yellow. So if I look at it, that's going to be negative x. Now, remember from this step, we want to take that number and we want to multiply it times both terms here, right? So it's going to be negative x times 2x and negative x times negative 1. Okay, so when I multiply negative x times 2x, I get negative 2x squared. Those should be identical. Negative x times negative 1 is positive x. And then I'm going to draw a line. And remember on this line, we subtract. So it's going to change this to a positive and this to a negative. Those should cancel. If they don't, you've done something wrong. 5x minus x is 4x. I'm going to bring down that negative 2. And then we're almost done. We're going to look one more time. Here's my first term. Here's the term I'm multiplying into it. So how many times does 2x go into 4x? It goes 2 times, yeah? So I'm going to hit plus 2 right here. And then I want to multiply the 2 times the 2x and the negative 1. So I'm multiplying by 2 times 2x, which is 4x, and 2 times negative 1, which is negative 2. And then remember, on this line, the signs change, and I subtract. And on this problem, everything cancels. So in this case, we say that this is a remainder of 0, or you could say that this is a factor of the original, right? 6x squared minus 6x to the third minus 5x squared plus 5x minus 2. Sorry, that got super messy. Right, so for our answer, all we have to write is this bit right here. That would be our simplified answer after we've divided. So that's long division, you guys. Let me show you one using synthetic division. So with synthetic division, the only difference, well, there's a lot of differences, but the problem is set up the same way in the beginning, right? The big difference is we have to use the root, not the factor. So you want to solve whatever's there, set it equal to 0, and you're going to get x equals negative 1. So this is super important only when using synthetic division, okay? So if you're using synthetic division, make sure you find the root or it's not going to work, all right? Now, once I have that root number, I'm going to put it right here and make a little box around it, right? And then I'm going to grab all my coefficients from my numbers. So the coefficient that's in front of x to the 5th is a 1. Then, because I am missing an x to the 4th term, I actually have to put a 0, right? So notice right here it goes from a 5 to a 3. Because the x to the 4th is missing, we can assume or actually know that it has a 0 as the coefficient. So I have to put that or it's not going to work. All right, and then I have a negative 3x to the 3rd. Then do you guys notice you're missing, this is a 1, right? So you're missing the squared term. So we're going to have a 0x squared. So I want to put another 0, and then my 2, and then my negative 5. Okay, so from here, I draw a line right under. So step 1 was getting the root right here. Step 2 was just grabbing those coefficients and not forgetting to put in zeros as you're missing descending powers of the exponent. Okay, now to start, I want to bring this 1 straight down. That's the first step. Now everything's going to be multiplication and addition. Okay, so I'm going to multiply this times this, 1 times negative 1, which gives me negative 1. And then I add those together. 0 minus 1 is negative 1. Then I'm going to do it again. I'm going to multiply this times this. So negative 1 times negative 1. This time that's a positive 1. Add these numbers. Negative 3 plus 1 is negative 2. Then I want to multiply again. Negative times negative. Negative 1 times negative 2 is 2. Bring that down. That gives me a positive 2. Keep multiplying. 2 times negative 1. Negative 2. That gives me 0. Negative 1 times 0. 0. Bring that negative 5 plus 0. Negative 5. Now, this is technically your answer, okay? But we have to write it in the correct form. So realize that when you do this, your answer will be 1 power less. Oh, not always 1. Let's say, actually, let me change how I'm saying this. Let's say it's going to, sorry guys, decrease by the power you divided by. So, because, let me make sure that you understand what I'm saying. Because we divided by an x plus 1 here, right, the answer is only going to go down by 1 power of x. If it was an x squared that I was dividing by, then it would go down by a power of x squared, right? So since it's an x, I know my answer is going to start with an x to the 4th because my top numerator had a to the 5th, right? So I'm going to grab all of these exponents, or these coefficients, sorry, from up here. And I'm going to write them in descending power starting with x to the 4th. Here we go. So my answer is going to be x to the 4th minus x cubed, because both of those are 1s, minus 2x squared, plus 2x, plus 0, which I don't really need. And then that extra little number out there is our pesky little remainder. So we take our remainder and we write the number as the numerator. And as the denominator, we write our original divisor. So x plus 1, right, is my remainder. All right, you guys, so get those down. I'm going to give you 2 that I want you, actually just 1 that I want you to practice, whichever way you choose, and then you'll be good. So So I want you to do this problem. And you may either do that using long division or synthetic division, and I'll check this tomorrow. Thanks.